Hello viewers, welcome to my YouTube channel. I'm very grateful for those of you that are subscribed, and if you are new here, please try to help me to subscribe and click on the notification bell so that you get a notification anytime I uploaded a new video. So today we are seeing mathematics. We want to look at complex number. What is complex number? A complex number is a mixture of real number and imaginary numbers. A mixture of real numbers and imaginary numbers. This is what I'm saying. A complex number is the mixture of a real number and an imaginary number. So the mixture or combination of a real number or an imaginary number. So it can be expressed mathematically as z equal to x plus iy. So let's call it equation 1. So this x here is our real number, and this y here is the imaginary number. I here can also be written as j. So let's define the terms. That is, x is equal to the real number of z, written as real number of z is equal to x. So we can write it that the real number or the real value for this z is x, and y is equal to the imaginary number of z, written as im of z equal to y. That is, the imaginary number of z is y. So we have real number and imaginary number. For us to understand this better, let's explain this symbol I, or it can also be j. Consider this a quadratic equation. The symbol I. Let's consider this quadratic equation. Quadratic equation. Let's say you have x squared minus 1 equal to 0. And you agree with me that if we solve for x here, we are going to get x is equal to plus or minus 1. That is, x is equal to 1 or minus 1. That will be the solution for this quadratic equation. And you know how I got this? I moved this to this side. To the x squared is equal to 1. And when you take the square root of both sides, you are going to have plus or minus because it's quadratic equation. And consider this as well. Consider this as well. X squared plus 1 is equal to 0. How do we solve this? So this will be x squared equal to minus 1. And this will be x equal to plus or minus square root of minus 1. And we can also write this as x is equal to root minus 1 or minus root minus 1. Now, there are some things we want to consider here. If you look at this equation has the real numbers 1 or minus 1. But consider this equation. We cannot find the real number here because it is very clumsy in order to express our x in this form. So we can find another time which we can use to replace this, because in the normal way, if you use our calculator to press it, it's going to tell us that the equation does not exist. But for us to make the equation exist, then we convert it to imaginary number. And in that form, we normally use, let our I be equal to square root of minus 1. Or we can also say our j is equal to square root of minus 1. So anywhere we see I now or square root of -1, we can easily put I, or we use j. So we can now say from this expression here, or from this equation, that the solution for the normal solution for this equation will be x equal to plus or minus I. That is, we can say x is equal to I or minus I. This I or minus I is telling us that we are taking imaginary numbers. So we have real numbers and imaginary numbers. And that is why from the definition we said a complex number is the combination or addition or mixture of real number and imaginary number. To further our explanation, let's take another example of a quadratic equation. Consider this equation: 5x squared minus 6x plus 5. 5x squared minus 6x plus 5. Let's consider this equation: 5x squared minus 6x plus 5 equal to 0. This is a quadratic equation, and from our knowledge of quadratic, we understand that the quadratic form is written as ax squared plus bx plus c is equal to 0, right? And here, if you solve the solution for this quadratic equation, we arrive at x is equal to minus b plus or minus square root of b squared minus 4ac all over 2a. This is the solution for this quadratic equation. And if we are to use this formula, which is quadratic formula, to solve this equation, you agree with me that we're going to have our a equal to 5, our b equal to minus 6, and our c will be equal to 5, right? So let's substitute to this quadratic equation. We're going to have our x to be equal to minus b. So by the time we substitute this, we're going to have 6 plus or minus square root of b, and our b is minus 6, and when we scale it, it's going to be 36, right? So minus 4 times a. And what is our a? Our a is 5, then times c. Our c is what? It's also 5. All over what? 2 times 5. So let's simplify this. So if we simplify this, we are going to have this to be 6 plus or minus square root of 36 minus, so this times this is 25. 25 times 4 is going to be 100, right? All over 10. And this can give us 6 plus or minus square root of minus 64. By the time we subtract this from this, so we're going to have minus 64 all over 10. But the question is now, what is the value for minus square root of 64? We understand that our solution for this cannot be 8 or minus 8, because the square root of 64 can either give us 8 or minus 8, provided that we have a minus here. Therefore, the square root of minus 64 can never be 8 or this. And as a matter of fact, that is one of the reasons we call it complex number. That is complicated. So it has to be a mixture form. How do we solve this? If you now understand the knowledge that our I, we define our I to be square root of minus 1, you can easily further this equation by saying this can be written as our x equal to 6 plus or minus square root of minus 1 times square root of 64 all over 10. Okay? So if you separate this and this is still the same thing as minus 64, we can now put the value, which is now 6 plus or minus, our I is square root of minus 1 is I, as defined here. So we can now write 64. Square root of 64 is 8I all over 10. And this can be written as 0.6 plus or minus 8 or 0.8I. So the solution for this equation now is now 0.4 plus or minus 0.8I. So the real part of it is 0.6 and the imaginary part of it is 0.8. So the measure of this is what referred to as what? As a complex number. But how do we operate complex number? Let's look at addition and subtraction followed by the multiplication of a complex number. So let's see this example, addition and subtraction of a complex number. So we have two questions before us which we want to attend to now. We have to simplify. So this is normal addition and subtraction of a complex number. It's very simple. It's still the same thing as the way we are operating the real numbers. So let's solve this question. The first one is 5. We have 5 minus 9i minus open bracket 2 minus 6i plus 3 minus 4i. So to do this, you see the way of normal operation. So what we are going to do, let's open this bracket first. This can be written as 5 minus 9i minus times this minus 2, then this times this plus 6i plus 3 minus 4i. So what we are going to do now is we grouping. So let's grouping, the like terms. So what are the like terms? The real numbers are 5, 2, and 3. So we have 5 plus minus 2, then plus 3, and the imaginary number are minus 9i plus 6i minus 4i. So if you operate this, we are going to have a 6. Okay, so this will give us 6 minus so if you operate this as well, so 6 minus this, that is 4, 2, and let's apply the negative side. So minus 9 minus 14 minus 4 will give us a minus 13. A minus 13 plus 6 will give us what? Will give us a minus 8i. So this will be our answer. So minus 13 plus this, so this will give us 7. Sorry. So this is 7. So the second one is 5 plus, so let's look at the second part of it. 5 plus 7i plus 3 minus 4i minus 6 minus 3i. So this will give you 5 plus 7i, so plus 3 minus 4i minus 6 plus 3i. So the real numbers will be 5 plus 3 minus 6, and the imaginary numbers are plus 7i minus 4i then plus 3i. So let's operate. This minus this will give us a minus 3, and 5 minus 3 will give us a 2. This will give us 2. Then 7 minus 4 will give us 3. So 3 plus 3 will give us a 6i. So this is our answer, or we can also simplify if we like. 2 into 1 then plus 3i. So this is our answer. So now let's look at multiplication and division. So let's look at multiplication and division of complex number. So we have question before us here. Given that z1 is 3 plus 4i and z2 is equal to 2 plus 5i, find the multiplication of z1 and z2 and the division of z1 and z2. So how do we solve this? So let's look at the way of solving this. So here our z1 times z2 is equal to, this is our z1, so we have 3 plus 4i times, so this is our z2, 2 plus 5i. It's normal multiplication. We are going to have a 3 into 2 plus 5i, then plus 4i into 2 plus 5i. So see, remember the law of brackets. So here we are going to expand this. 5 2 times 3 will give us 6, plus 3 times this will give us 15i. Then when you expand this, it's going to give us a plus 8i. And when you multiply this and this, will give us a 20i squared. So here, this and this can be added. We're going to have from here, we're going to have a 6 plus, so when you add 15 and 8, so 15 plus 8 will give us a 20 what? 23. 23i, then plus 20i squared. So don't forget that our I squared, if you remember, note that our I is equal to square root of minus 1. So if you want to find I squared now, if you square this, we are going to have I squared equal to minus 1. So instead of writing I squared, we can replace I squared by minus 1. So this will give us z1, z2 to be equal to 6 plus 23i, then plus 20 into minus 1. So this will give us 6 plus 23i minus 20. So this and this will turn to real numbers. So we're going to have 6 minus this will give us a minus 14 plus 23i. So this will be the solution for A. And let's look at the solution for B. Z1 divided by Z2. So B, Z1 over Z2 will be equal to, what is our Z1? This is our Z1, which is 3 plus 4i all over Z2, 2 plus 5i. Okay? So in solving or operating a division, what we need to do is we apply the law of sort. If you see, remember, if we are dividing sort, we can easily rationalize by the conjugate when we have two terms of that sort. So here we are going to rationalize by the conjugate of the denominator. You agree with me that the conjugate of 2 plus 5i will give us 2 minus 5i. So the conjugate of 2 plus 5i is 2 minus 5i. We are going to rationalize this numerator and the denominator by this conjugate of the denominator. So we can now say that our z1 over z2 is equal to 3 plus 4i all over 2 plus 5i times the conjugate, which is 2 minus 5i all over 2 minus 5i. So by the time we multiply this and this, we discover that the solution will be real numbers. So here we are going to have this as 3 times this and times this again. We are multiplying it by this. So this times this times this. So you see the same thing, writing 3 times 2 minus 5i, then plus 4i into this. So which is this and this. Same thing as 2 minus 5i all over. So this times 2 minus 5i, then plus 5i into 2 minus 5i. So let's expand this. So if we expand this, we are going to have 3 times this will give us 6. So minus 15i minus 15i. So we are done with this. This time this will give us a plus 8i. So when you multiply this and this, it will give us a minus 20i squared all over. So when you multiply this and this, will give us 4. So So 2 times this will give us minus 10i. So this times this will give us a plus 10i. So this times this will give us a minus 25i squared. So when you simplify this, you are going to have 6. So minus 15 plus 8 will give us what? Will give us a minus 7. Minus 7i. So this will be minus 20 into, don't forget that our I squared is the same thing as minus 1. When we put it here, we have minus 1 all over 4. This will take care of this. So we now have a minus 25 into minus 1. Our I squared is minus 1 here. So by the time we simplify this, we're going to have 6 minus 7i, then plus 20. Minus times minus will change to plus. So this will be 4 minus this time this will change to plus 25. So we can now have two real numbers here, which is 6 plus 20 minus 7i all over this plus this will give us 29. So the answer for this will give us this plus this will give us 26 minus 7i all over 29. And this can be written as 26 over 29 minus 7 all over 29i. So the real part of this is this, and the imaginary part is this. Thanks very much. These are what we can say concerning complex number. Next time we are going to solve complicated questions on complex number. If you are new here, please try to subscribe to my YouTube channel. Just click on the notification bell so that you quickly get a notification anytime I uploaded a video. And those that have subscribed, I'm very grateful. I can see your work. Please, you can share to your friends. If you see any question you want me to work on, I can help you with the time I have. Thanks so much.